Tired of slow build times, endless code reviews, and environments that just don't scale with your team? Most dev teams are drowning in delays, from 22-day PR cycles to failed local builds that killed momentum. Every hour wasted waiting on Docker builds or chasing down environment issues is costing your team productivity and your company money. In this video, I'll show you how DevZero transforms developer efficiency with real-time dashboards, AI-powered insights, and dynamic cloud workspaces built for speed. Stick around to see how platform engineers can finally deliver environments that ML and dev teams actually want to use. Let's dive into the dashboards and launch a live Jupyter Notebook workspace right now. Let's get started and take a look at our dashboards that DevZero exposes to us. And the first one is the Developer Experience Index, or DXI for short. And it's really made up of two components, DORA and ODA, or Open Development Analytics. And what happens is that there is an AI that runs behind the scenes and looks at all the metrics across these two components and comes up with a team speed score, as you can see here. In addition to that, it gives us some recommendations and it sees some of the things that we might improve on. We got 3 here: build times take too long, code review delays, and dependency version conflicts. Give us some kind of a severity score and a recommendation to each one of these. So here we can see we can implement caching for repeat builds as an example with some recommended tooling, like creating storage volumes and a recipe. Now let's dig into each one of those dashboards. The first one is DORA, and if you click on go to dashboard, it takes you to the dashboard. This is your traditional DORA metrics that you would expect. Things like PR cycle time. So in this case, we see 22 days per PR. We have here the PR throughput, which is the number of PRs merged into productions, 5 per week. And PR failure rate, time to PR review, 81 days. This is a good metric to keep an eye on. You want to reduce this and bring this down to 0 as you can. So we see here we're down to 27.2, and this is again the time from a PR creation to the first human review. So you want this as fast as possible. Also, another good metric, average time to first commit. You also want to see this come down to 0. So we see here we're at 4.37 hours from the first time a person gets onboarded to their first commit. We also see distribution of time to first commit across your developers in your environment. So we got 9.17 hours, 17.9 hours here. The next dashboard is the ODA, or Open Development Analytics, with a few metrics that we can take a look at here. And we can also break this down either by a workspace, which is a DevZero workspace in the cloud, or a local machine that a developer is working on, so their local workstation or laptop, or you can flip it back to both. So some of the metrics here, like local development efficiency, commands that are executed, we see 215 commands over the last 6 hours. Failed commands, we have 39, which is 18%. And we see idle time, which is an important metric here, 2.9 hours. It measures how long you're spending time waiting for commands to execute. Maybe you're running a Docker build and it's taking 5 minutes, right? So you want to reduce the idle time as much as possible. Another metric here is looking at the commands that are executed, what are successful and what are failed commands. I see make, for example, has 12 successful commands here and 1 failed command for make. We got npm, git, go, kubectl, docker. Also, the execution times for the repo commands that we saw here, but in terms of seconds. So here we got npm ran for 5.48 seconds. And on the right-hand side, we see some insights that we have here. Make build, for example, is the command with the most failures. The slowest command we saw is npm run build, and gives you an idle time cost per hour, active developers. And then the next metric is execution times for all processes, which is a nice metric to look at because this kind of shows you the difference between running your processes locally versus inside of a workspace. And as we would expect here, that it would take longer to run commands locally than inside of a workspace that's hosted in the cloud. This is a DevZero workspace, and you have a lot more resources inside of a cloud environment or a cloud workspace. That's why these commands will probably take shorter time. And again, this could be a nice dashboard to show to upper management, to show them how much more valuable it is to run your processes inside of a workspace rather than on developers' local machines. And the final metric here is memory and CPU consumption per process. You can see that per the npm, Docker, Go, and so on, the processes we just saw. It's worth mentioning that all these metrics are available also in Grafana. So you can click on the Open Grafana button here and you'll see all of this in Grafana. We can just go back in time just to see some metrics. And there we go. So you can see some of these metrics that we saw before inside of Grafana, which is really neat to see. And with all these metrics at your fingertips as a platform engineer, you are able to improve. We always say that you cannot improve what you cannot measure. Thanks to the DevZero dashboards that are exposed to us, we just saw DORA and an ODA. We're able to see what's going on in our development shops. Now, for the rest of the demo, imagine I'm an ML engineer and my platform engineering team has created a recipe for me for Jupyter notebooks, and I want to launch a workspace with a Jupyter notebook in it. So I can go ahead and select this Jupyter notebook. And for this notebook, we can go ahead and launch it and give it a name. And go ahead and launch. And while this workspace launches, let's go back to our recipe and see what is inside of this recipe. So first off, the build stage, we have a couple of steps. We're installing Python 3 virtual environments, and we also are activating the virtual environment. And in it, we're going to install some libraries like NumPy, Pandas, and so on. And then in the launch phase, we're going to run the Jupyter notebook with port 8888. And we have our command that will run right when we launch. And this is to activate the virtual environment and, of course, to run the notebook. From there, we can run the notebook in a browser or in Visual Studio Code or Cursor, however we'd like to work with this notebook. All right, looks like our workspace is ready to go. So we can click on it right here and we can go ahead and either connect via Visual Studio Code or Cursor, or we can connect directly by opening our Jupyter notebook like this. And we can go and interact with it directly from within the browser. And I'm already on the network, the DevZero network. So that's why I'm able to privately access my Jupyter notebook directly from my machine. And from here, we can go ahead and create a new notebook. So like that. And I can start to interact with my notebook. I have a few cells I want to put in here. So this cell, and we're going to add another one. And this is just an example. It generates some large synthetic data, and then we're going to train a model here really quickly to show you how this all works. Let's go ahead and run first cell, the second cell. And then finally, let's go ahead and run the last cell. From here, all we're doing is we're graphing CPU usage over time as we go ahead and train our data inside of this workspace. Okay. But this is a quick demo to show you how you can provide Jupyter notebooks to your ML team, that they can leverage a workspace that you can create for them, or they can create it from a recipe that you've created for them. And they can go ahead and interact with this notebook and work with that. Now, while this runs and trains our data, I want to take you behind the scenes and show you really what DevZero is doing. They're using MicroVMs, and MicroVMs are lightweight virtual machines that can run multiple container workloads on a single host. And the container workloads basically are hosting our workspaces. So they can combine the security and isolation of traditional VMs with the efficiency and speed of containers. And on top of that, we're able to migrate and move those MicroVMs between different nodes or instances, depending on the workloads that are going through and dynamically allocate different instances. So it's pretty neat where you can see here we have a bunch of CPUs, 4 CPUs with some memory. And if the workspace needs more resources, you can see we can start to dynamically allocate more CPU, more memory. We're used to static workloads or static assignments where if you're using Kubernetes, for example, you create requests and limits. And this graph here shows you what exactly we're trying to do with this dynamic resizing, where you might have a static allocation up here, and then the actual workloads that's going through the request, you can see this purple graph here. And what we're trying to do with dynamic resource allocation is to minimize the delta between the static allocation and the workload requests. And that way we're as efficient as possible in terms of usage of our resources. Now, confidential compute is a concept that is specific to MicroVMs, where we can run each container in its own secure MicroVM, where we're leveraging hardware virtualization to prevent containers escaping to the host node, while of course maintaining that near container level performance. The top benefits that we have out of all of this is cost reduction. Since we're dynamically and efficiently allocating resources, we can reduce cloud cost, speed in terms of caching, scaling, and observability that we saw at the beginning of this video. And as you can see, the use cases here, there are 4 of them, but the one that I'm excited about the most is the AI ML use case. And we saw in the demo where I showed you how we were training a model and we were specifically using CPU, but if we find that we have a need for GPUs, we can seamlessly move a workspace from using CPUs to GPUs and share a cluster with isolation. So what's exciting is that DevZero just announced multi-tenancy for GPUs in collaboration with NVIDIA to allow multiple tenants to share a cluster with complete isolation. And you can read more about it in this blog post here, and you'll see a link to it as well. Building secure multi-tenant AI clouds, how DevZero leverages NVIDIA BlueField 3 DPUs and big technology. So give this a read and see the new technology that DevZero is coming out with and how this can benefit your organization as you efficiently provide development environments to your internal customers. To wrap things up, DevZero gives you the visibility, speed, and control your team needs. From real-time insights with DXI, DORA, and ODA metrics to secure, scalable workspaces for ML and dev teams. This is how you cut costs, boost performance, and keep developers moving. If you're serious about developer productivity, it's time to level up your platform strategy. Thanks for watching, and I'll see you in another video.